Welcome to my YouTube channel, Data Pulse by Mose, the heartbeat of data learning. If you're new here, please make sure you subscribe to support me, and if you're a returning subscriber, I'm happy for you, and that keeps me motivated to keep sharing more content. Okay, so now let's get into our topic of the moment. And then we have data structures. Data structure is a special way of organizing and storing data in a computer so that it can be used efficiently. So in Python, we have 4 different data types or data structures. First, we have lists, and then we have tuples, we have sets, and then we have dictionary. So these are the main data structures that we have. As we proceed or as we continue, we see how do we create the lists, how do we create the tuples, how do we create the sets, and how do we create the dictionaries. But I don't want to get there before we actually get to that point. So let's start with list indexing. When you talk about indexing, we have values stored in an array, right? So we can access a value from this list using index. And we have 2 ways of accessing our values from our list. First, we can do positive indexing, or we can do negative indexing. When I talk about positive indexing, it's the case where we are indexing from the left side to the right side. And then negative indexing, we are indexing from the negative side or from the right side to the left hand side. So here is an example. We have a length of 5 characters, PROPE. So when we talk about positive indexing, we start from 0. We have 0, 1, 2, 3, and 4. And then negative indexing, we have negative 1, negative 2, negative 3, negative 4, and negative 5. So this is why we are doing indexing. If I want to access a value, a character R, I can either use 1 or negative 4 to access that character. And then one thing I want you to note is for the positive indexing, we start from 0. But for the negative indexing, we start from negative 1. Right? So that is the idea of list indexing. So let's see what we have here. List is a collection which is ordered and changeable. It allows duplicate numbers, and it is mutable data type. So what do we mean here? When we talk about allowing duplicates, it means we can have multiple values of similar type. For example, I can have, let me define a list L. Yeah, I can have 1, 2, 3, 3, 4, and then 3. Yeah, so here I am able to have multiple duplicates of a value 3. So it allows duplicate numbers. Another thing about list is that it is mutable. When I talk about mutable, I mean we can change the values of a list. That is what we mean by mutable. And then we have if we want to represent a group of individual objects as a single entity where insertion order is preserved and the duplicates are allowed, then you should go for the list. We will see why we are talking about this. Yeah, we will get to know which data structure is not mutable and when do we use that data structure. But for the lists, I want us to understand that lists are immutable. That means we can change the values of the lists. Lists are duplicates. Yeah, all allow duplicates. That means we can have duplicate value in a list. Yeah, so if you want to have for example, the student marks, you want to record the student marks, you can change the student marks at any time. Yeah, so in that case you can go for the list. And then we have different operations we can do in our list. First, we can check the length of our list. When I talk about when I say checking the length of a list, I mean checking the total number of values that I have in my list, right? So 1 2 3 4 5 6, so it will give me a total of 6 total number of values. So in that case we use the length method, len, to check the total number of values that I have in my list. Another thing we can do in a list is we can do concatenation. Concatenation means I can combine multiple lists. I can combine two lists, yeah, using the addition sign. We'll see another ways that we can do concatenation or list concatenation. Yeah, and then we have repetition, whereby in repetition we can have a list repeated multiple number of times. Yeah, for example, here we are trying to repeat a list high 4 times. Yeah, so we can get high appearing 4 times in a single list, right? And then we have membership. Membership is simply trying to check if a given value is in a certain list. Yeah, and the output of this membership is a Boolean result, either true or false. So in this case, I'm trying to check if 3 is in my list 1 2 3. Yeah, so it returns true because you can see we have 3 in our list. So that is the membership operation. And then iteration, of course we can iterate through a list, that is printing the value of a list through a for loop iteration. This is simply some of the operations that we can do in a list. So here is a detailed operations. Other operations, we have sort, we have index, we have count, clear, reverse, remove, delete, pop, insert, append, and reverse. So these list operations are basically actually list operations. These operations comes in when you actually when we use them, the methods. Talk about sorts, we have a sort method. Talk about index, talk about count, we have count method. So all these comes into play. Okay, we can use this when we are in form of the methods. Let me say something again. Let me check for my pen. So when you want to create a list, creating a list, we have a variable. So you have a variable list, right? And then we have box brackets. Yeah, we use box brackets to create the list. So you can have your list 1 2, or I say 3 2 4 and then 8. So you have your list. We use the box brackets to create a list. So now you have this list. Maybe you want to do sort, you want to do append, you want to do insert. Yeah, so let's start with for example the sort. So the sort, we have a method to decode a sort. So we have sort, and then we have the parentheses. Yeah, parentheses also we call them the brackets. So this we call them parentheses in programming. So sort simply is just sorting the elements of a list in ascending order. Yeah, that is from the smallest to the largest. For example, I have my list and then I want to sort these values. I could say I have 1, I have 2, and then 3, and then 4, and then 8. Yeah, so that is sorting. Simply rearranging the elements in ascending order from the smallest to the largest. And then we have the index. Just as we said, index is simply about returning the index of the first occurrence of the specified value. Yeah, returning the first index of the first occurrence of the specified value. For example, we have this. So I specify my value as index 0. I will return the value of the specified index. I say, for example, index -4. I will return the character R, which is a specified index. Yeah, so that is something about index. And then we have count. The count method or the count list operation is used to return the occurrence of the specified value in the list. Yeah, to return the number of the specified value in the list. For example, I'm trying to check the actual amount of the actual values I have in, for example, in my list. I want to check how many times, for example, 1 occurs in my list. Yeah, so I will specify the count. I'll use the count method, and then I will specify the value I want to get, the number of times it is appearing in this list. Yeah, so the count method will return 2 for the case of 1. Yeah, so I have 1 which is occurring 2 times, so it will count the number of times my value 1 is occurring in my list, right? And then we have clear. Whereby clear, the clear list operation, it removes all the elements from the list. So if I have my list and then I want to remove all these elements from my list, and then I will remain with an empty list, I will use the clear method to remove or to delete everything from this list. Yeah, so it will simply removes all the elements from the list. And then we have extend, whereby the extend list operation appends the elements of another iterable list. Yeah, for example, we want to add some elements to another list. We use the extend method to add those elements, to append those elements. Yeah, I guess that is clear up to that point. And then we have the append. We have the append list operation. So the append adds a single element to the end of the list. So assuming I have this list, I want to add another value to this list. So in that case, I will use append method to add a single element to the end of this list. So for example, I can add let me say 3. Yeah, so I have appended a value to my list. And then we have insert. The insert list operation, it inserts an element at a specified index. Remember, append inserts to the end of the list, but for the insert, append adds an element to the end of the list, but for the insert, it inserts an element at a specified index position within a given list. Yeah, so if I have insert, I can specify that I want to add my value, for example 9, to this index. So I will say I want to add after index 2. Remember, this is index 0, index 1, and then index 2. So I will say insert at index 2, and then I specify a a number or a value that I want to insert. So insert is used to insert a value at a specified index. And then we have the pop. The pop removes and returns the element of the specified index. So that is if you specify the index that you want to pop a value. A pop means you want to remove a value from a list. Yeah, so if you specify an index for the pop, you can remove a value from that index. For example, I can say pop value at index, let me say index 2. Yeah, so I will pop a value 2. But if I don't specify the index for the pop list operation, I will simply get rid of the last element from my list. That is, if I don't specify the index. So by default, the pop method removes an element from the last remove the last element from the list. And then we have delete. Delete removes the first occurrence of the specified value from the list. It removes the first occurrence of the specified value from the list. So the pop, here we said if you specify the index, you remove that element from that index. Also, if you don't specify the index, you remove the last element from that list. Then we have delete. Delete is also used to remove an element from the list. So here you don't specify the index. Yeah, here you can specify the exact value you want to remove. For example, I can specify I want to remove a value 3. Yeah, so this will remove the value 3, not the value at index 3. And then we have remove. The remove list operation removes the first occurrence of the specified value from a given list, just like the delete. Yeah, so these methods actually these three methods or these three operations are used to remove values from the list. The append, insert, and extend are used to add elements to a list. Then count, we said, is used to check the number of times a given value occurs in a list. Sort, we said, is used to rearrange values in ascending order, right? And then we have reverse, whereby reverse list operations, it reverses it reverses the order of the elements in the list in place. Yeah, so for example, if I had my list 1, 2, 3, or let me have a different list. I have a variable L, and then I have a list 1, 2, 7, and then 6. So it will reverse the order of these elements. So in the reverse method, I will start with 6, and then 2, 7, 2, and then 1. So it will reverse these elements. Yeah, so this is actually the list operations that we have. I guess that is well understood. And then we have tuple operations. Yeah, so for the list, what you need to understand is lists are immutable, lists allow duplicates, list can be accessed through the index. Another thing we've said, list can be, we can append a value to a list, we can insert, we can pop, delete, remove, reverse, extend, clear, count, index, and sort. Yeah, and then we have tuple operations. So tuple is exactly same as the list, except that they are immutable. You cannot change the values of a list of a tuple, sorry. So that is, once we create a tuple object, we cannot perform any changes in that object. Therefore, a tuple is read as tuple is a read-only version of the list. Remember, you have said we can pop a value from a list, we can append a value from a list, we can remove a value from a list, but for the tuple we cannot do any of these operations. Yeah, So to create a tuple in Python, we have let me give you an example. We have tuple, let's say tup. This is my variable, and it will store my tuple object. So I have tup, and then we use parentheses. Yeah, we use parentheses to create the tuples. So I can say I have 1, 2, 3, and then I have 4. So this tuple, once I create this object, I cannot change any value from this tuple object. Yeah, so this is how we can create the tuples. So if our data is fixed and it never changes, then we should call for the tuple. So if you don't want any changes in your data, for example, let me give an example of marks records. I have the marks records of my students in my class. So I don't want anyone to change these marks. I could use a tuple to declare these student marks, yeah, so that no one can change the marks of these students. So that is, this data is fixed, yeah. We cannot change any value from our tuple object. And then another thing about tuple object is insertion order is preserved and duplicates are not allowed. So we said, remember we said in lists we can have duplicates, but in tuples we cannot have duplicates. Another thing is we can preserve insertion order and we can differentiate duplicate objects by using the index. Therefore, index will play a very important role in tuple also. So just like in the lists, we also have indexing in tuples. Yeah, we said in list we had negative and positive indexing. Similarly in tuples we have positive and negative indexing. So the positive index means forward direction, just as we said, that is from the left to the right. And then negative index means backward direction, that is from the right to the left. So that is positive indexing and negative indexing. I hope we understood what we did in the list in terms of the indexing. And then we can represent tuple elements with parentheses. That is what I've already said. So this brackets is what we refer to as the parentheses, and with the comma separator. With the comma separator. Parentheses are optional but recommended to use. So this is the thing. You can declare the tuple objects using the brackets, or sorry, the parentheses, or you can simply declare the tuples without the parentheses. So I could say I have 1, 2, 3, and 4. This is the same thing, but it is recommended to have the parentheses in place. Yeah. So that is how we can create the tuple objects. So just like we okay, for the list operations we said we have different operations, but here we say the tuples are immutable, so we don't have much operations on the tuple object. So what you need to understand here is how we create the tuple objects. Yeah, and then you need to understand that the tuple objects are immutable. Once we create this tuple object, we cannot perform any changes to that object. So that marks the end of the second data structure. The third data structure we're going to talk about is the set operations. Yeah. Set. Yeah, so if we want to represent a group of unique values as a single entity, then we should call for a set. In sets, duplicates are not allowed. Insertion order is not preserved, but we can sort the elements. Index and slicing are not allowed for the set. So how do we create the set? We have our set. Let me have a variable set. Let me see this. I say this is my set. And then to create a set, we have what we call as curly braces. Yeah, curly braces. So these curly braces are the ones that we use to create our sets. And then we have the values for our sets. We can have 2, 3, 4, 5, and let's say 6. So this is my set. We have curly braces, and then each character value is separated by a comma. So that is how we create the sets. And then we have different set operations. Yeah, we get here. So set objects are immutable. That means we can change the value of the set. So once we create a set object, we can perform any changes in that set object based on our requirements. So we can create you can represent set elements within curly braces, just like the way I said, with a comma separation. That is how we create the sets. We have the set curly braces, and then with comma separation. So we have different set operations. The first set operation we have is union. We have intersection, difference, and asymmetric. So here we're going to use two examples of sets. We have set A. Let me say we have set A. Let's use this set A, and then we have set B. Yeah, so we have two different sets with their values. Let me say we have 1, I have 2, I have 3, I have 4. And then here, let me say I have another set. I have 1, no, sorry, let me say I have 5. Let me say I have 4. Let me start with 4. I have 5, and then I have 6. So I have two different sets. And then we have these operations. We have union operation, intersection operation, and then we have difference operation, and then we have symmetric difference operation. So how does union operation work? So a union operation is a set of all values that are a member of A or P, that are a member of A or P. Let me say this. Let me say I have this 1, 2, 3, 4, 5, and 6. So I want to get set. I want to get set A. Let me say set A union set P. Yeah, set A union set P. Yeah, so we've said set A union set P is a set of all values that are members of A or P or both. So we'll have set A whereby we have 1, 2, and then 3. And then we have union set P. We'll have 4, 5, and 6. Yeah, so we have all elements of set A or P or both. Okay, let me assume we had duplicates. Yeah, let me assume we had duplicates. We had the same values for set A and set P. Let me say we had set A 1, 2, 3, and then set P we have 3, we have 4, then we have 5. So here we have 3 in this case, and then we have 3 in set A and set P. So set A and set P has 3 in both cases. So we have set A union P. Set A union P. So this will return all the values that are members of set A or P or both. What we'll have? we'll have 1, we'll have 2, 3, we'll have 4, and then we'll have 5. So we use 3 only once. We don't repeat 3 2 times. That is in the case where we have a value that's appearing in both set A and set B, right? So that is for the union operation. And then we have intersection. Remember we said sets does not allow duplicates. Duplicates are not allowed. Yeah, that's why I did not use 3 2 times. Yeah, so we cannot have duplicates in sets. So let's go to intersection. A intersection B. Yeah, so we have set A intersection set B, whereby set A intersection set B is a set of all values that are members of both A and P. That are members of both A and P. So what this means is we only return the value that is appearing in both sets. Yeah, so assuming I have set A, let me go this way, A intersection P, A intersection P. So I will only return the value that is appearing in both sets. Yeah, so I will only have, for this case, I have 3 here and then I have 3 here. I will only return 3 because it is a set of value that's in both set A and set B, right? So that is for the intersection set operation. And then we have difference set operation. So A difference P is a set of all values of A that are not members of P. Yeah, members of A that are not members of P. That is difference set operation. Okay, let me say I have A difference. We can talk of we can use a minus P, or we can use this backslash. Yeah, or we can say we have A difference P. Yeah, so here that means we'll only have the members that are of set A. Yeah, but not members of set P. So here we'll have 1. So remember I'm using this still same example. We'll have 1 and 2. That will be the difference set operation. Yeah, that is A difference P. I will not use 3 because it is appearing in set P. So we'll have only 1 and 2. What if we have P difference A? That is set P difference A. P difference A. So here, in this case, I will have only those values that are appearing in set P, but not in set A. So I will have 4 and then 5, right? So that is for the case of difference A, P, right? So that is the difference set operation. Another set operation is symmetric difference. So the symmetric difference is a set of all values which are in one of the sets but not both. Which are in one of the sets but not both. So here we have set A and set P. Yeah, we have set A and then we have set P. So set A symmetric difference set P. So what we get here is the set of the values that are in set A and set B but not both. So we not have these three value as in our symmetric difference set operation. So we'll have 1, we go to 2, and then 4, and then we'll have 5. So that is for the symmetric difference set operation. I hope up to this point everything is clear, but if you have a question you can ask before we go to dictionary. Okay, silence means no question. Then we go to dictionary, which is the last data structure that we have. So dictionary, okay, you can speak. You can just open your mic and speak if you have a question.
No, it was a mistake, please. Thank you.
Okay, fine. Then we have dictionary set operation. Dictionary operation. So this is some of the features of a dictionary. Dictionary keys are not allowed, but values can be. Sorry, duplicate keys are not allowed, but values can be duplicate. Insertion order is not preserved. Dictionaries are immutable. Dictionaries are dynamic, and indexing and slicing concepts are not applicable. So let's go, let's try to understand how do we create dictionaries and what do we have in dictionaries. So for dictionaries, let me have a variable, let me say dic, dict. You can speak if you have a question.
Yes, what do you mean by duplicate keys are not allowed, but duplicates can be done?
Yeah, okay, I'm going to show you that. Yeah, okay, I'm going to show you what I mean. Yeah,
All
so
right.
yeah, let's understand how we create the dictionaries. So we have a variable. I have my variable dict. This dict is going to store my dictionary. So in dictionary, we have two things. We have two things. First, we have keys, and then we have the values. And then to create dictionary, we use the curly braces. Yeah, we use the curly braces. So inside these curly braces is where we define our keys and the values. So key and the value means, for example, I'm trying to define the student marks. Yeah, I will have the student names and then the marks. Okay, let me give you an example. Let me say I have name. Yeah, I have name, and then I have marks. I have name and then I have marks. So here is my full colonies. So this will represent my key, and then this will represent my values. Yeah, okay, so let me say this is name or student ID. Student ID. Remember we said keys are not duplicates. We do not allow duplicate keys. So I cannot have same student ID in a single dictionary. But I can have similar marks for students, different students' names, or for different students' IDs. Yeah. So here we have our key. Yeah, and then we have the values. As we go along, we will be able to see how we create the dictionary and then be able to convert the dictionary into a data frame. When we talk about a data frame, we mean data in form of rows and columns. We have records and then we have columns. Okay, so for dictionary we have two parts. We have the keys and then we have the values. Now let's create a dictionary of student names or student IDs and then the marks. Let me say I have the dictionary 2, okay, dictionary 1, and then I want to have the student ID. Yeah, so I can say my student ID is for example 001. So this is my student ID. So this student ID has the marks, yeah, has the marks of different subjects, yeah. So I will store these marks in a list, right? For example, I have 60, I have 70, and then I have 50, right? So I have the student marks in a list. So this will be my values for my key 001, which is for my student ID 001, which is my key. So this is the key and this is the duplicate. Sorry, this is the value. So this is my first student ID. Again, I can have another student ID. So I have a comma, yeah, and then I have another student ID. I can say 002, 002, full colony, and then we have the student marks. So I can have 60 again. I can have 55, and then I can have, okay, let me say 20, right? So this is my second student student ID. So 001, 001, and 002. So I want us to understand, we have these keys, we have these student keys. So this key should not be duplicate, that is what we mean. And then we have the student marks. So we can have 60 duplicate marks for different students, yeah. So that is how we create a dictionary. So this dictionary, we can be able to convert it to a data frame. So for example, I can have 0, 01, I can have 0, 0, 2. So this is my two different students whose marks is, for example, 60, 70, and 50. And also here I have 60, I have 55, and then I have 20. So this will be my case, this will be my case, and then this will be my values. So that is now converting a dictionary to a data frame. We'll get here when we'll get here shortly. For now, let's understand how we create dictionaries, and then we have the keys, and then we have the values. So in our practical, we'll be able to see this. We'll be able to understand it, I guess, more clearly. So that wraps up the dictionary operation. How we create the dictionaries and how we the different operations we can do, all the different things we can do in our list dictionary.